Hello, we are at learn.detroitbonesetter.com. We're going to go over the answers to mbcase 2. So here's mbcase 2. Notice first that there's two columns, and that's because at times the slice through the femoral neck may not be good for one side or the other. So in this case, this is a very good slice down the femoral neck. This is the good one for the femoral condyle, and similarly on the left side. So we're going to start with the right side. We're going to do femoral neck, distal femur, and ankle. And then again, keep in mind net femoral version and net tibial torsion. That's basically the what we're getting paid for, is to figure out what the answers for that is. So we'll start with selecting an angle, choosing a line of best fit down the femoral neck and a reference. Similarly for the distal femur condyle. And for the ankle, and you can do some adjustments. Make sure that you're pretty accurate here. Okay, so for your femoral neck, in blue, we're going to round 25 degrees of internal rotation. The distal femur in green, 14 degrees of internal rotation, and the ankle in yellow is at 34 degrees of external rotation. Now keep in mind that those are the static images, and you need to add or subtract them to figure out what the net version or torsion is for each segment. For the femur, we need to, at least the way I understand it, bring your femoral condyles flat to the ground. So what you're going to need to do is externally rotate 14 degrees. As you externally rotate 14 degrees here, you're still going to be left with some internal rotation at the femur, because the femur has 25. So you're going to have to decrease it. So it's going to be 14 minus 25, which is 9 degrees. Sorry, I'm using my calculator. 11 degrees. It's embarrassing. 11 degrees. And keep in mind, again, as the femoral condyles are rotated flat 14 degrees, you're still left with 11 degrees of the femoral neck pointed internally rotated. That is called retrotorsion or retroversion. Now, we did discuss in the course the difference between the two, so the real correct term is retrotorsion, but it may also be known as retroversion. For the tibia, again, rotating this flat, you'd have to externally rotate 14 degrees. You already have 34 degrees of external rotation, so that's going to be added. So 14 at the distal femur plus 34 is 48 degrees of external tibial torsion. Okay, so now we'll move to the left side. I'll just copy and paste this left side, okay? So for the left side, we're going to do the same thing. Select an angle down the femoral neck, line of best fit, angle along the femoral condyle axis, and one parallel to the floor, and then an angle through the syndesmosis. And you can adjust those. Just keep in mind, some people prefer not to use the distal femur as a surrogate of torsion for the tibia. Keep in mind, the distal femur would be a reasonable representation of the proximal tibia, assuming there's no intra-articular rotational instability, which is not always the case. Some people do prefer to use the proximal tibia as the proximal axis for tibial torsion. All right, so we're going to go to the left side. The femoral neck in turquoise is 15 degrees internally rotated. The distal femur is purple. That's 17 degrees of internal rotation, and the tibia in orange is 26 degrees. 26 degrees of external rotation. So I'll just delete this, not to confuse anyone. So for the left side, we're going to rotate the purple, the femoral condyle, flat to have it make sense in your brain, or at least in my brain. So in order to do that, you'd have to externally rotate 17 degrees. So you're going to rotate this 17 degrees external, and this is going to be externally rotated. It's at 15. So what's going to happen, it's going to be 17 minus 15. Okay? At the end of it, you're going to rotate this 15 degrees plus 2. So 17 degrees, so you're going to get, you'll be left with 2 degrees pointed external. So that would be 2 degrees of antiversion or anti-torsion. For the tibia, you'd have to rotate this external. This is already external, so you're going to add those. So the purple is 17 plus the orange is 26. So it's going to be 17 plus 26. Unfortunately, I need my calculator for that. 17 plus 26 is 43 degrees of torsion. So on the right side, the patient has 48 degrees of tibial torsion. On the left side, 43 of tibial torsion. So similar torsion on both sides. Of note, the patient has significant disability with his right lower extremity. And I thought it was coming from his femur rotational deformity. So this patient has 11 degrees of retrotorsion on the right, 2 degrees of antitorsion on the left. So if we wanted to go one step further and say, what is the magnitude of the deformity? Magnitude of the femoral deformity. We're talking about, right, axial angulation or rotation. Then you'd have to take the 11 degrees of retrotorsion, 2 degrees antitorsion. So you'd have to add those. So there's a 13 degrees of rotational deformity. This assumes, of course, that the left side is normal, or you want to, if you would correct it, you would surgically correct it to his left side to make it symmetric. So the next question is, which way is it deformed? So the right side is retroverted. So that's an externally rotated deformity of the distal segment of 13 degrees on the right side. So if we were doing surgery on the right femur, we would cut the femur and we would internally rotate the distal segment on the right femur 13 degrees in order to match the left side of 2 degrees of antiversion. All right, I hope that makes sense. Thank you for paying attention and have a good day.